This video is on preferences. Now, preferences depict how an investor trades off risks and rewards of an investment plan. Preferences are also unique to investors. They can account for monetary characteristics and for non-monetary considerations, such as whether investments align with the ethical, moral, or environmental compass of an investor. Casually speaking, preferences over investment strategies characterize the degree of happiness that are associated with a particular investment decision. Now, economists represent preferences via utility functions. Preferred decisions receive higher yields. So a utility function describes an investor's portfolio preference by a numerical index. Early work in financial economics has worked with preferences on wealth only, therefore ignoring any non-monetary considerations. Now have a look at Figure 1. It depicts the shape of a typical utility function. The x-axis shows different levels of wealth that an investment could create in the future capital T. The y-axis quantifies how happy the investor feels about each potential investment payoff. Also note that on the x-axis I'm highlighting two states of the world that could occur in the future: a poor state and a rich state. The hypothetical investment that I consider pays off €1 in the poor state and 999,999 euros in the rich state. It's evident that higher payoffs are preferred over lower payoffs. Moreover, as a general rule, future wealth itself is not a direct measure of the investor's happiness, but rather an input to his utility function. The only exception to that rule is when the investor is risk neutral, which graphically speaking means his utility function is linear in future wealth. For any other risk-averse investor, a utility function is concave. So why is the utility function concave? Well, consider the following. If the poor states get realized, your investment pays off only €1. You would really prefer to increase your wealth level by an extra euro in order to pay for all your expenses and obligations. On the other hand, in the rich state, your payoff is close to €1,000,000. While more money is always better than less, you wouldn't assign much extra yields to an additional euro. Why would you? You are a millionaire in that state already. So a euro more or less just doesn't matter at all. That intuitive feature of utility functions, namely to imply diminishing marginal utility in wealth, is a natural property of a concave utility function. So let's talk about bad versus good times. And that means we have to talk about marginal utility. So marginal utility is high in bad times and low in good times. Bad times are states of the world where wealth is low and the respective utility function is very steep. In Figure 1, That is exactly what is happening in the poor state. If your wealth were to drop any further in that state, your utility would fall drastically. Said differently, marginal utility is very high in that state. That says that you regard in such a state an additional euro very, very highly. Now, in contrast, good states are associated with times where the utility function becomes rather flat. In figure 1, that happens in what I've called the rich state. The value of an additional euro in that state is close to 0. This means that marginal utility is very low in good states. And therefore, in a way, investing for retirement is a bit like boxing. Long-run success depends largely on how well you can master these bad times.
Got feedback? We would love to hear it. Please drop us a line. And if you liked the video, give it a thumbs up. And don't forget to subscribe to the channel.